You know, it's kind of magic, isn't it? How the internet just works. You type a website name, hit enter, and bam, a whole world of information just appears. But behind all that magic is this system. This absolutely fundamental, elegant system you use hundreds of times a day without even realizing it. So today, we're going to pull back the curtain on that magic. We're diving into the internet's global phonebook.
I mean, really, stop and think about that for a second. In that split second between you hitting enter and a website loading on your screen, what is actually going on? A dizzying, lightning-fast chain of events kicks off, and it's pretty incredible.
Well, it all starts with a simple translation problem. See, we humans, we think in names, right? Like example.com. Easy to remember. But computers, they speak in numbers, specifically IP addresses. Think of them like a unique street address for every single thing connected to the internet. The problem is, these two languages are totally different. We need a translator, fast.
And that translator is the DNS, or the Domain Name System. Now, the best way to think about it, and this is a perfect analogy, is as the phonebook of the internet. It's this massive, global system that takes the name you type in and instantly finds the right numbers so your computer can connect to it. Simple as that. Okay, so how does this giant phonebook actually work? Let's do this. Let's follow a single request you make on its, well, epic journey across the internet just to find one little number. It's a really fascinating trip.
So your one little request doesn't just go to one place. Nope, it gets handled by a team, a cast of 4 different types of servers, kind of like a relay race where each one has a very specific job to do before passing the baton to the next.
The first character your request, or query, meets in this relay race is called the DNS Recursor.
Think of the recursor as a super helpful librarian. You walk up to the desk and tell it the name of the website you want, and it's the librarian's job to go run all over the massive library of the internet to find the exact answer for you. It does all the legwork.
So where does our librarian go first? To the very top, to something called the root name server. The root server is like the main index at the front of our huge library. It doesn't know the exact location of example.com itself, but it knows which general section to look in. It sees the .com at the end of the address and basically tells our librarian, okay, you need to head over to the .com section.
So, following those directions, our recursor now zips over to its next stop, the TLD, which stands for Top-Level Domain Name Server.
So this server is in charge of a specific aisle in our library, the .com aisle, the .org aisle. You get the picture. We're getting warmer. The TLD server doesn't have the final answer either, but it knows which specific bookshelf holds the record for example.com.
And that pointer brings us to the final and most important destination in this whole search, the Authoritative Nameserver.
This is it. The Authoritative Nameserver is the actual dictionary on that bookshelf. It's the final source of truth. It holds the definitive record. It flips open to the example.com entry, and right there is the IP address. This is the aha moment where we finally find the answer.
Okay, let's put all the pieces together and actually trace that full path. So it starts with you. Your browser sends a query to the DNS Recursor, our librarian. The recursor, since it doesn't know the answer yet, goes all the way to the top and asks a DNS root name server. The root server points it in the right direction, saying, go talk to the .com TLD server. So following that lead, the recursor then makes a request to that TLD server.
And now for the home stretch. The TLD server responds with the IP address of the one server that has the final answer, the authoritative name server for example.com. Our hard-working recursor sends its final query to that address. And at long last, the authoritative server returns the actual IP address we've been looking for all this time. The recursor then passes that number all the way back to your web browser, and just like that, the connection is made. Mission accomplished. Now, you might be thinking, whoa, an 8-step process, that sounds kind of slow. But the internet is incredibly clever. That full journey, it almost never has to happen, thanks to a beautiful process called caching. Caching is pretty much the internet's secret weapon for speed. It's like after you look up a phone number, you jot it down so you don't have to go back to the phone book every single time. Caching just keeps a temporary copy of the answer much, much closer to you.
And this temporary memory isn't in just one place. It's stored in a whole chain of places, creating all these amazing shortcuts. Your browser itself has a cache. If the answer isn't there, it checks your computer's operating system, which has another cache. And if it's still not there, that DNS recursor that first got your request probably has the answer saved from the last person who asked. Every single level is another chance to get the answer instantly.
So what's the end result? What's the ultimate payoff of this fantastic system of shortcuts and temporary memory?
Near instant connection. Seriously, the vast majority of times you visit a website, you're getting a cached answer that's maybe just one step away. This whole system is what makes the modern web feel so immediate, so responsive. So we've seen the mechanics. We've gone through the nitty-gritty. But let's just step back for a second. Why is this invisible, behind-the-scenes system so incredibly important?
Well, when you boil it all down, DNS is what makes the internet usable for us humans. I mean, without it, we'd all have to memorize long strings of numbers just to check our email. No thanks. It delivers the incredible speed we all expect through that clever caching, and its decentralized design is strong enough to handle the entire planet's internet traffic day in and day out. It just works.
And look, if you remember just one thing from all this, let it be this right here. This simple analogy is honestly the most powerful way to understand what DNS really is and the absolutely vital role it plays for every single one of us. So we've pulled back the curtain on one of the internet's most critical invisible engines. It's always there, working flawlessly in the background. It kind of makes you wonder, right? What other fundamental systems are out there powering our digital world, just out of sight?